Hello, I hope this video finds you well. We're going to work through this Dwight Programming Contest problem. It's from 2004, problem 1, area of a circle. Really nice problem from a really nice contest that no longer runs. And you can find all the solutions as well as the old problems online. And I have a link to some really good resources in the comments. So this problem is called area of a circle. And essentially, given the Cartesian plane coordinates x1, y2, and a point on the circle's circumference x2, y2, we want to calculate the area of the circle. It gives you in this section right here, it gives you the formula for the area of a circle, and it gives you the formula for the distance between 2 points, and it gives you a value of pi to use. It's really important that you use this value of pi, because otherwise you're going to get a value which is correct. But again, because in contest situations they're marked by a program, and if you get a different precision level, you're not going to get it right. Now, with this contest, you had to read from a file and write to a file. I'm not going to do that. I'll make some later videos to talk about how to do that. But in this case, this video, I just want to understand how to do this problem. So we'll take one input, process it, and then do the output for that one case. And what's important here to take note of is the range of values. And it's always good to take note of what are the possible values, because sometimes in contests, people try and deal with bad inputs. And that makes the problem sometimes a lot harder. All right. So essentially for this problem, what we need to do is step 1, oh, that's totally the wrong language. Step 1 is we need to take the inputs. Now, what I like to do here when I'm doing contest problems is I actually just like to assign those input values. So the first one is 2, 4, 4, 8. So I'm just going to say x1 is 2, y1 equals 2, y1 equals 4, x2 equals 4, and y2 equals 8. The reason I'm doing this is because I know the inputs are correct. I can just double check them based on the sample input. There it is. And there's the sample output for those values. Also, when I'm getting into harder contest problems, it takes time to kind of, or not harder, but longer inputs. It takes time to type those in, and I make mistakes. So by doing this, I just know it's there. Okay. Step 2 is find the distance between the center, or find the radius. Find the distance between 2 points, which is the radius. So we're going to do this and say d equals, and we're going to take the square root. And with Python, we can do that by using the double star notation. So I'm going to say star to the power of 1 over 2, because the square root is the power of a half. And then in here, I'm going to work out the formula. So that is going to be y2 minus y1, and that's going to be squared, so star 2, that's the power of 2, plus x2 minus x1, and then we're going to square that. And now I have the distance. So step 3 here is take the distance and find area. So again, the area is equal to pi. And now I might use a constant, a built-in constant here, but because this problem gives me the value for pi, which is 3.14159, I need to use that exact value, because only by using that value will I get the same precision that is required when I round it to 3 decimal places. And again, a computer will mark this. It always pains me when students do these wonderful solutions but miss these details and then end up not getting it right because a computer does it, they've done it to 4 decimal places or are more precise than what it needs to be. Times radius, and again, that's radius squared, so I can do this. That's radius squared. And I'm going to print out A. And that's all I have to do. Now, a lot of the students are preparing for the Waterloo CCC, which is a wonderful problem contest. And for the Waterloo CCC, you just have to take inputs and you just have to print out an answer. There's no files to deal with. So this is step 4. We're going to find or print area. Okay, so let's run this now. Now, when I run this, I like to run it through the terminal. A lot of people will use different software where you can just run it, but I think this is good when students are learning how to do this. So I'm going to say Python 3. There's the problem. I hit enter. And I don't get anything because notice I haven't saved it. So let's save this now. Let's try that again. And I get an error. R is not defined. Because I didn't write this as R. How many of you guys caught that? Let's set that as R. And there we go. So I get an answer, but notice my answer is obviously not the same as what I expect. It's expecting 62.832. So I need to round this. So we're going to round it right here. I'm going to call this step 3.5. Now I'm going to show you 2 ways to round it. One way is to use the built-in function. So I'm going to say a is equal to round. And round is a standard function that's in the standard library in Python. And the first parameter I pass is what do I want to round is a, and I want to round it to 3 decimal places. So if I do it this way, and now run it, I get the value, and there it is. So 62.832, 62.832, beautiful. If I change to the second case, 112, so let's come in here. Let's go 1, 1, 2, oh, what was it? 1, 1, oh, 1, 1, 1, 2. Pardon me. I don't want to open up Adobe. 1, 1, 1, 2. We save this and run this. 3.142, 3.142. I feel good about this. Okay, let's just show you the second way to round, just because I think this is a good technique to have in your toolkit. If I want to round it, if I change this just to say round A, and I run this now, that just rounds to no decimal places. So what I can do is, if I take the decimal and I move it and I put the decimal in the place for the precision I want and then move it back, it works out nicely. So if I say A is equal to A, and if I multiply it by 1,000, and that's going to move the decimal 3 places to the right, then I round it, and then I divide it again. This has the same effect, and it's a good technique. Is using the built-in function with the second parameter like this better? Totally. But I like to highlight this technique because it gets students thinking about how to manipulate float values to kind of do different things with them. All right, now with the Waterloo CCC, I know I'm doing a Dwight problem here, like I said, this contest would read from files, but we're not going to do that. What we need to do is take inputs from the console, and we need to print it out. So I'm going to now take this and modify this to take inputs. So I'm just going to do this as standard input in Python, standard input in Python, standard input in Python. There we go. And now what this does is when I run this, it sits and waits and wants to know the value. So I say 2, 4, 4, 8. And notice I have a problem. So what the problem is remember in Python, when I take a standard input, it assumes it's a string. And a string you can't perform mathematics with. So I have to actually cast this, and I want to cast it to a float. So there's 2 ways I can do it. I can do it in 2 lines. So if I take this function here, float, and I say, okay, take whatever x1 is and cast it to a float, and casting is the process of changing type. A lot of times you'll see people write it like this, which is a little bit easier, where they actually write the input inside here. So I take my input, and then whatever the result is, I cast it. And that's how I'm actually going to write it here, just because it's a little, But again, as a beginning programmer, sometimes, students will often really want to get as short a length of code as possible. And sometimes it's beneficial, but, having longer code that's easy to read is actually really quite wonderful. So we do that, we run that, and now I can put my input in 2, 4, 4, 8, and there it is. Okay, so that is the Dwight problem, 2004 problem 1, area of a circle. Again, what you would need to do now is you have to set this up to read from a file and then write the answer to a file if you're writing a contest that had files. Requirements. Maybe before I go, I'm going to do one last thing, and it's going to seem irrelevant, but as we get into harder contest problems, this is actually really useful. So what I like to encourage students to do is, when they're doing contest problems, is to make a function and just take your problem and shove it in the function, and then just invoke it. So what this does is, now that entire problem is inside a function, and then I call it. So what the problem does is, the program reads all the way through, hits the bottom, says, oh, run that function, comes back up here. For this problem, this is total overkill. But the beautiful thing about this is, by putting it into a function, you can return from that function as soon as you find an answer. So problems that tend to be a little bit harder, this is a really nice way to stop your program with a return statement when you hit that point. And we'll see that in some later examples. I hope this video helped. If you have any questions, please don't hesitate to reach out. Have a wonderful day.